So page 14 from the Foundation Revision Guide or workbook is operations of fractions. So we're going to do that in this video. For question 1, we are adding two fractions and they start with different denominators. So we've got a bit of a guide to help us out here. To add fractions with different denominators, we need to make the equivalent fractions over the same denominator. So the lowest common multiple of 3 and 5 is 15. So the first fraction has been multiplied by 5. So the top number is also multiplied by 5. To get from 5 to 15, we times by 3. So we would need to times the numerator by 3 as well. So that would give us 6 out of 15. And then when we have them over the same denominator, we just add the numerators. So that would be 11 over 15. For part B, and again, we've got a guide here. So we need to put them over the same denominator, which is going to be 20. To do that, we would need to times the first fraction by 4. So the top number is going to become 16. And the second fraction we've multiplied by 5, so the top number, the numerator, will be 5. And then 16 take away 5 is going to be 11 over 20. Okay, and then for C, our lowest common multiple of 7 and 8 is going to be 56. So the first fraction would be times by 8. So 6 times by 8 is going to be 48. And then 6 times by 7 is going to be 21. And we're adding this together, so that's going to be 69 over 56. And I'm just work out, so arguably that would be absolutely fine for my answer. I would argue that a better answer would be to convert it into a mixed fraction. So that would 56 goes fully into 69 one times fully, and we would have 13 left over. So I would argue that that's a better answer. And then for part D, again, we're going to put these over a common denominator, and this common denominator is going to be 63. To do that, I'd be timesing the first fraction by 7. So we're going to have 35, and the second one by 5, so we would have 36. And I've made a mistake there. Let me just try and pick out what I've done wrong. No, I don't think I have made a mistake. We're just going to have a negative answer here. So we've got minus 1 over 63. Okay, question 2 then, we've got some multiplying and some dividing. So I always cancel before I multiply where I can. I can't simplify first of all in this one though. So I times my numerators and I times my denominators. 1 times 1 is 1, and then 2 times 3 would be 6. For the next one, we are looking at, again, I would cancel if I could, but I've got no numbers diagonally in common. So it's going to be 5 times 3 is going to be 15, and then 11 times by 4 is going to be 44. And then I'm not a fan of how this is written. I always try to keep mathematical language where I can. So I would say that dividing by a fraction is the equivalent to multiplying by its reciprocal. So I would change the divide to a multiply, and I would take the reciprocal, which kind of means flipping the numerator and denominator over. And again, this is the first one where I can actually do my diagonal cancelling. So 5 and 10 have 5s in common. So 5 goes once into 5 and twice into 10. So 4 times 2 is going to be 8. And then 1 times 3 is going to be 3. And that would be absolutely fine. But I would say that that would go in fully. 3 goes fully into 8 twice, with 2 left over. So I would say that 2 and 2/3 is a slightly better answer. And for the next one, same process. I'm going to write the first fraction down, and dividing by a fraction is equivalent to multiplying by its reciprocal. And I've miswrote. And then I can cancel diagonally quite nicely twice in this one. So I can cancel by a factor of 3. And over here, these two numbers have 2 in common, so I can cancel by a factor of 2 as well. So 1 times 3 is 3 over 2, or 1.5. And I would go for that as my better answer. Okay, question 3. A man wins some money and decides to give it to his 3 children. Andrew receives 2/5 of the money, Ben receives 1/3 of the money, and Cara receives the rest. Work out the fraction that Cara receives. So we're starting by adding those two fractions. We need to put them over the same denominator. So the lowest common multiple of 5 and 3 is 15. To do that, I would times the first fraction by 3. So my numerator needs to be times by 3 as well. So that would be 6. And then my second fraction has been times by 5. So that's going to become 5 over 15. And then we can just add the numerator. So that's going to be 11 over 15. So that's the amount of money that has been accounted for. And if we want to work out Carla's share, I'm going to do 1 minus 11 over 15. Well, 1 would be 15 over 15. So 15 take away 11 is going to be 4 over 15 for Carla's share. Just questioning the set out, I don't really think we need another equals. I think 4 over 15 is the best answer. And then question 4, a garage has a supply of 210 litres of oil. Amy uses 4/7 of the supply and Brad uses 1/5 of the supply. What fraction of the supply is left? So a bit like the earlier question, we're going to have to start by trying to add these two fractions together. And to do that, we're going to have to put them over the same denominator, which the lowest common multiple of 7 and 5 is going to be 35. So I'm multiplying the first fraction by 5, so that's going to become 20. And I'm timesing the second fraction by 7, so that's going to become 7. And then when I add those two together, I'm going to get 27 over 35. So that's the fraction of the supply that's been used. So the fraction that is left is going to be 1 minus 27 over 35. And again, 1 is going to be the same as 35 over 35. So that's going to be 8 over 35. So how much oil is left? So this is what is left. Like with my earlier questions, 8 over 35 of times by 210, I would always tend to do this as 8 times by 210 divided by 35. And then 35 goes into 210. If we think about it, 35, 70. So I'm going in my 35 times table. So 35 times 2 is 70. And then 70 would go in 3 times. So that's going to go in a total of 6 times. So 8 times by 6 is going to be equal to 48. And that is topic 15, or page 15, operations of fractions.